Okay, A313. Okay, looking at it here. Let's get us caught up here. Come on. Catch up to us here. It's systems of linear equations. Remember, we did this back in chapter 6. It was a pretty tough chapter. You're going to find some of these problems can get a little long. But here we go. It says in problem 1 that line M and N form a system of linear equations. What is the x-coordinate of the solution to the system of linear equations formed by lines M and N? Okay, all they give you are the some points on two lines, and what we need to find is that intersection. In particular, we want to know what the x-coordinate is. So we're looking for that intersection. So we've got to find the equation of both lines and then solve them either, well, we can't see it graphically what it is, but solve it either with substitution or elimination. Okay, so let's take a look at what we got here. Blue, boom. All right, so we've got 2 points here on the first line, and I'll use the, come on, where we at here? Get my pen, here we go. So the first one was the point 0, 4 and 3, 0. Okay, I'm going to try to find the equation to that line right there. We'll start out with, we got to find the slope first. So 0 minus 4, 3 minus 0. So I'm going to get negative 4/3. Okay, my other point was 5, negative 7, and 8, 2. So my slope for this line, 2 minus a negative 7 over 8 minus 5. I get, it's plus positive, so I get 9 over 3. I get 3. Okay, so let's see here. We're going to find the equation here. I'm going to use y equals mx plus b. And for this one here, if I take the point 0, 4, I'm going to get 4 equal to negative 4/3 times 0 plus b. That cancels out. 4 is my b. So y equals negative 4/3 x plus 4. That's the equation of that line. Let's find the equation of this line. Using the same y equals mx plus b, I'm going to take the 8, 2 and plug it in. I'm going to get 2 equal to 3 times 8 plus b. That's a positive 24, so I'm going to subtract it over. So I get negative 22 as my b. So y equals 3x minus 22 is my equation here. They're both equal to y, so I'm going to set them equal to each other. Negative 4/3 x plus 4 equals 3x minus 22. Let's see. I'm going to multiply everything through here by 3 to get rid of this fraction. So it's going to cancel there. I'm going to get negative 4x plus 12 equals 9x minus 66. I'm going to add the 4x over here. It's going to give me 13x. I'm going to add the 66 over here. It's going to give me 78. Divide out the 13. 6 is my x. Okay. Check the answer there. 313, 6 is the answer. So you're either going to put it in the first box or the last box, but 6 is your answer. Okay. A lot of work to that one. Just the way it is. Problem 2. At Florida Tech, the number of male students in the thermodynamics class is 6 times the number of female students. The total number of students in the class is 56. The graph below can be used to determine the number of male and female students in the class, where x represents the number of female and y is the male. So they gave you the x and y. You can see it right here, x female, y the number of male. Let's see, how many female students are in the class? So again, we're looking at the intersection here, and you can use the graph. In this case, you can clearly see that it's intersection is at 8:48, so it's 8 female students just from the graph. Put the 8 here or put the 8 here, that's fine. Okay, so we're solving this one graphically and they already gave it to us, so we're good. Moving on. Problem 3. Todd correctly graphed the system of equations below on the coordinate grid. So they give you 2 equations in standard form. Which graph represents a system of equations? Test taking strategy here. Okay, they give you the intersection of each of these. Okay, so a simpler way would be to take an intersection like 2, 2 here and plug it into both equations for x and y and see which one works. If 2, 2 works, then that's your intersection. If that doesn't work, you can use it over here, or you can use this one, or you can use this one. Okay. What I'm going to do for you here is I'm just going to go ahead and solve them for you using the elimination method so you see that method one more time. So let me erase this region here. We got all of this good stuff. Cha-ching. We're back here. So I'm going to start up here. We've got 5x minus 3y equals 16. And we've got 4x plus 5y. Oops, it's a y right there. I don't know I'm right in there. Equals -2. Okay, so it's your choice. Pick whichever you want to do. I've already got a plus and minus here, so I'm going to cancel out my y's. So 3 and 5 both go into 15, so I'm going to multiply by 5 here and 3 here. So when I rewrite that first equation, I'm going to get 25x. Make sure you multiply by each and every term. Minus 15y equals 80. Now times 3 on the bottom here. So I'm going to get 12x minus 15y equals -6. Add them up. My y's cancel out. I get 37x equal to 74. Divide the 37 over. X is 2. Okay, you want to find y? Plug it back into either one of these. I'll take that second equation. 4 times 2 is 8 plus 5y equals -2. Subtract that 8 over. I get 5y equal to -10. Y is equal to -2 when you divide out the 5. So my intersection, 2, -2. Okay, so let's go back here. 2, -2 is right there. It's the only one that has 2, -2. So your answer here is D. You look at that on the answer sheet and it is correct. Okay, so that's it for that one, and we'll come back, start on 3:14 the next time. All right, hopefully this